Hi, welcome to this class. In the past, I've made videos already on such functions, but where f of x is a straight line. I'll link the video right up now because if you have not done that, you should do that first before you do that of a quadratic function. It's a prerequisite. Okay, there are actually two videos. I actually also did one where the modulus sign here has a negative in front, but where f of x is a straight line. So you want to take a look at that. Please go ahead and go into my channel and watch and subscribe and learn. But for this particular one, we are looking at f of x where f of x is a quadratic, and I've put an example on. So you can see, sketch the graph of y equals to the modulus of 2x squared plus 5x minus 9. So take a look at some steps that we should thread. The first one will be to plot the basic function. Okay, we need to plot the basic function y equals to x squared plus 5x minus 9. And one way to do that is, first of all, to write your equation in the form of 2 into x plus maybe h all squared plus k. Again, I have a video for that. Just check up right now. You see that I'll link it so that you can go watch it. I have numerous examples that will help you to understand that properly. Okay, but that will be our first step for this video. The second step will then be to find the intercepts, both x and y intercepts. Okay, intercepts. We need to find the intercepts. Then the third part will be to then look at the minimum value. We pick the minimum value. It's a minimum because this graph is positive, and you can tell because the coefficient of x squared here is positive. So it's going to be a minimum because it's a cup rather than a cap. Okay, so we look for the minimum value. These are things that are crucial to plotting the graph. I'm not sure we need anything else aside these three. Having then sketched the graph of y equals to 2x squared plus 5x minus 9, we must then go ahead to sketch the modulus function y equals to the modulus of 2x squared plus 5x minus 9. And then our job will be done. Okay, so to do this, let's get cracking. The first one, of course, is to look at step 1 up there. So let's do that. I'm going to block this off a little bit so that it's a bit tidy. Okay, so y equals to, I've got to factor out 2 because it's essential that the coefficient of x squared is 1. So plus 5 over 2x minus 9 over 2. Okay, now what I'm going to do is complete the square by doing this. Again, follow the video link I would have dropped earlier to study how to use completing the square. Okay, so 2 into x squared plus 5 over 2x. Now to complete the square, here we go, plus 5 over 4 all squared, then minus 25 over 16, which is the same thing as 5 over 4 all squared, then minus 9 over 2. Okay, that is completed. If you want to know what I've done, well, you would need that video. Please go and watch it. However, just to mention it a little bit, what you do is you look at the coefficient of x here, find half of it. So half of 5 over 2 is 5 over 4. Okay, then you square it. Okay, that's the quantity that you are adding to it. But because the quantity was not there in the first place, you also have to take it out so that this expression is not changed, okay, in value, in size. So whatever you add that wasn't there before, take it out also, so that essentially you still have the original trinomial, which is x squared plus 5 over 2x minus 9 over 2. So once you have done that, well, your job is all but done when it comes to completing the square, because it is this is why we then write this as 2 into, well, x plus 5 over 4 all squared. This that I've written here is actually equal to this trinomial If you want to be sure, just expand it. This will give me minus 97 over 16. Okay. Now if I distribute 2, just to make it less cumbersome, I would have 2 into x plus 5 over 4 all squared minus 97 over 8, which is the form we're looking at. To put it in proper perspective, let's convert this to decimal. Okay, now we have written it in that form of x plus h all squared plus k. Now to find the intercepts, we know the y-intercept, okay? The y-intercept is always the last digit here without the x. So the y-intercept in this case is minus 9. Please remember, we're not in this form, please. In this form, the y-intercept is minus 9. If you are going to find it in this form, then you have to make x 0 and solve. You're still going to get minus 9, okay? So we will write that the y-intercept is minus 9. Now we need the x-intercepts, which are the roots. Now to do that, what we need to do is to make this to be equal to 0. Why? Because we know that on the x-axis, y is always 0. So 0 equals 2 into x plus 1.25 all squared minus 12.1.25. Okay, if I take minus 12.125 to the other side, I divide by 2. So I will have 6.0625 equals to x plus 1.25 all squared. I take square root of both sides. If I do that, I will have x to be equal to root of 6.0625, okay, minus 1.25, or x will be equal to minus root of 6.0625 minus 1.25. And if I sort that out, calculate it, I get x equals to, so the x-intercept is 1.2122 or negative 3.7122. All right, now we have everything we need to sketch. Okay, the first thing will be now to look at the y-intercept, and it's at minus 9. So let's look for that. So that's negative 9 right there. The minimum will be at negative 1.25 and negative 12.25. I know that because you have to choose the negative of this one and you have to choose this one. Now let's use the minimum, negative 1.25. I like this to be negative 1. Okay, so negative 1.25 and negative 12, 10, 11, 12. So we could just say maybe that is here. Right, I'm not going to pay too much attention to the position right now because I'm still going to have to flip this graph up, well, the part that is beneath the axis. Okay, so we have the minimum. Now let's put the x-intercepts at 1.2. We could put that here, and then at negative 3, 1, 2, 3, 4. So negative 3.7, that's really close to 4. Okay, now you can see how the graph goes. Okay, so I have the sketch. Now the only thing that is left will now be to flip this over the x-axis. So some critical points to note: if this is negative 9, after flipping over, we should have a 9 also. 2, 3, 4, 5, 6, 7, 8, 9. So let's put a 9 there. So all I've got to do now is to bounce this up that way, take it back down. All right, so I'm done bouncing it. So this part that is beneath the x-axis, I'm going to now clean it off. The reason is simple. This modulus tells us that our graph cannot be negative. Whatever the value of this is, there is no way y will give you anything negative, because the modulus simply conditions your function to always be positive. Now this is the negative y-axis, which means we can't have our graph anywhere beneath the line y equals to 0. Okay, anywhere beneath this, the x-axis is giving you a y value that is negative. So if we like, we can label this as y equals to the modulus of 2x squared plus 5x minus 9. Okay, now this video was a little bit too long for my liking, so I'm going to, well, do another example, but that will be in another video. So I will link that video at the end of this one. Well, if you have been able to watch to the end, if you learned something, thank you for watching. Please remember to like and subscribe. That would do me a whole lot of good. See you next time. Bye.